Before we launch into the really complicated ones, I'd like to just make sure you get the basics. Would you please take a moment and find the 4 plus the origin makes 5 most important x-axis numbers and the y-axis numbers and graph sine on there. And I personally think it's easier to make the wave before you put the dashes on there, but just graph sine and label all of its key spots. This is what you're going to keep coming back to over and over and over. At this point, the cell phones go away. Mine is too. Put yours in your backpack. Don't have it sitting out of your desk. Too tempting. We like it. For some of you guys, so I always like to start on the end, right here. Jack, what is that spot right there? 2 pi. And then I like to go halfway back and say that spot, which was half of 2 pi, which is pi. And then I go half of that, which is pi over 2. And then I start thinking, and this is a really important skill, so think this through. Counting by whatever these units are. Because see, sometimes later, it's going to be like 1/12 of a pi units. Right now, it's just pi over 2. 2 pi over 2. 3 pi over 2. Oh, that's what that one is. Again, you might be like, oh, I've already memorized this. 3 pi over 2 server. Well, the thing is, sometimes you're going to be counting by weird stuff, and you'll need to know what this next mark is. Okay, so for example, imagine for a moment that I had these marks, and I said this was 8 pi over 10. What's the one in front of it? And then what's the 5th mark? Well, did anybody reduce 8 pi over 10 right away? What did you get? 4 pi over 5. Good. So then if that's 4 pi over 5, what's half of that? Because that's what would go here. Half of 4 pi over 5 is 4 pi over 10. Did you get what I did? I doubled the bottom. That's like timesing it by 1/2. You know, 1/2 of 4/5. And that'd be 4 pi over 10. Okay, so I don't get what you're talking about, sir. All right, so if this is 4 pi over 10, then this is 8 pi over 10. Then you can start counting by those. 4, 8, this would be 12 pi over 10. Would you give me the next 2 marks? (16 pi over 10) and 20 pi over 10. What does that happen to reduce to? 2 pi. So get used to counting by strange things. All right, so one more. It'd be really nice if it's this easy, but if they just told you the first mark was pi over 6, could you tell me what that mark is? When this comes in handy is when you're shifting them. Did you get this as 2 pi over 6? This is 3 pi over 6. This is 4 pi over 6. And this is 5 pi over 6. Raise your hand if you had 5 pi over 6. Okay. See how knowing that first mark makes it really easy? You just count by those. Okay. All right, so now imagine we had to do this one, and it's cosine, but cosine is a lot like sine. So everybody start by just graphing cosine right on here with the normal units. Don't get obsessed with changing it to this and We'll do that later. Right now, just draft normal cosine, and that's what you should do every single time. Graph the parent first. I like to think of it as a valley, and again, I think it's easier to label it later. There's the high spot, there's the high spot. That'd be 2 pi. All right, clean it up, and before you change anything, keep it the parent function. I'm going to ask you to compare with the kid sitting next to you. Okay, so did my heart good to hear somebody say, technically you're dividing by -4. That is correct. And so if I take this here and I divide it by -4, it's like multiplying it by -1/4. So this becomes negative pi over 8. Raise your hand if you had that one right. Awesome. Which way is this thing going to shift then? This is called the phase shift. Which way is it going to shift? Right or left? Yes, sir. Right is correct. It seemed like it would be left because it's a negative number, but things on the inside are opposite of what you'd expect. So it's going to go right pi over 8. Well, we aren't numbering in pi over 8s here. So the first thing you have to do, though, is handle this 4. Now, it's a -4. I promised you, and I will stick to this, that we would never make you do this on a test because it makes the whole graph flip this way, left, right. And those are really complicated. So I'm going to just remove the negative from the problem at this point, and you may also. Just take the negative out because we won't do it that way. It's too hard. So now this 4, remember this 4 is on the inside. Do we trust that 4? No. So we don't multiply everything by 4. We divide everything by 4, which is like timesing by 1/4. See how I'm going to get eighths? See, all of a sudden it's pi over 8. This is 2 pi over 8. I know it doesn't look like it's eighths, but it is. 2 pi over 8, 3 pi over 8, 4 pi over 8, and 5 pi over 8. Do you get now it won't be that hard to shift this thing over 1 pi over 8? Because we just renumbered the thing. And now it won't be that hard. It's not fun, but we would shift it to the right 1 pi over 8. So this graph, I really wish I had this ability in Notability to grab something and just drag it over. I can't. But I'm just going to like take the key points of it and show how they go over one spot to the right, and then I'll draw it in blue. So this blue one here, I'll make it darker blue, is my final graph that got shifted pi over 8 to the right. Okay, so that was rough, but as complicated as I can get. Here's one of the key skills that I noticed a lot of people struggled with. Let's say that I had, we'll do a simpler one, sine of 4x minus pi minus 1. I want you to try that as a graph. Start by graphing regular sine. Factor this thing properly. And this time we'll actually do this move down 1 at the very end when we're done with everything else. We'll handle that down 1. We didn't do that on the first problem because it was just too complicated. We've agreed as an honors pre-calc group, after talking to the calculus people, they don't ever need you to do this many changes to a graph on the AP Calc test. You have to know the basic graphs, like a lot, but you don't have to do super complicated things in AP Calc. They may give you 1 or 2 changes. They're not going to give you 4 things to do in AP Calc. Like stretch it, shrink it, flip it, you know, that's just too much. So this has only got, this is the most it could possibly have on our tests. 3 changes. It's got this stretch or shrink, and it's got this shift, and then it's got this move down. That's the worst it could be. So Jacob, what do you always start with? The classic sine graph. The classic sine graph looks like this. 2 pi, pi over 2, 3 pi over 2. This is a 1, this is a negative 1. How many of you guys started with the classic sine graph? Good, you've learned something. Now, for once, these aren't going to change because I don't have a vertical stretch on the outside of it. There's nothing out in front of here. So, tell me about the factoring, Robbie. Because if you can factor it, you should.
Yeah, you set it up. You have to take out the 4.
And what do you have left?
X minus pi over 4.
You got it. Now, I'm going to be doing something with my numbers here. Max, can you tell me what to do to each of my x values? It's based on this 4 here.
Divide by 4.
Yes. Notice I'm taking my 3 pi over 2, that was really messy, and I'm timesing it by a 4 on the bottom. That's like multiplying by 1/4 or dividing by 4. All right, now, this is a question we haven't talked about very much. The period was 2 pi. Do you get this thing as finishing up a complete cycle and it's not doing it in 2 pi anymore? It's now 2 pi over 4. That reduces to pi over 2. Now its period is pi over 2. Do you see how the period changed? Why? Because it gets a cycle done quicker. Why? Because of this 4 here, which made it finish up faster. It's like scrunching it down. It's not stretching it out, it's scrunching it down. It finishes faster. So instead of 2 pi, it finishes up in pi over 2. All right, so that's, this thing's period changed. And I only have 2 things left. I've done this 4. That's done. I got to do this shift of right pi over 4. That's how far pi over 4 is. It's 2 marks over. See, we skipped over 1. It's 2 marks over. So everything moves 2 marks over, and it looks like that. Now, you're going to get this wrong on the test if you leave it that way, because you haven't labeled these marks. And that's why it's really good to figure out what you're counting by. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and 6 pi over 8. And I'll actually tell you that since I think it's so important to know how to count by this, if you left it as 6 pi over 8, I wouldn't even mark it wrong, because I know it should be reduced, but I think too many times kids reduce stuff and then they don't know what they're counting by, and it's really hard for them to count. We're counting by pi over 8s. So then I knew that these last 2 were 5 pi over 8 and 6 pi over 8. So if you leave a graph like this where you've labeled the first 5 or 4, depending on if you count 0, 0, 4 or 5 spots, but then you move your graph over here and you don't number these, you will lose points. You got to have it labeled wherever the graph is. So if you move the graph over, add some more labels. So again, if you realize you were counting by pi over 4s, then you go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. That would be 5 pi over 4, and the last one would be 6 pi over 4. Okay, so that's another really common thing that people forget is if they shift it over, they've got to factor in the labeling. All right, last but not least, I said a -1 at the end. So that makes this whole thing move down 1. How far is 1? I can look at my labels. See, this is how far 1 is. So if I'm going to move it down, I'm going to move it down exactly 1. And now I'll do it in red. Now it's going to start here. And I think the smartest thing is to just take and put a mark 1 spot down for each key spot. Oop. There. The red one is the final answer. If you could, the blue one was my answer, but then the red one was moved down 1. Okay? All right. That's everything you have to know about sine and cosine and moving and flipping and stretching and all that stuff. So what else is in this unit? There's a couple other things. Gonna learn tangent tomorrow, and those graphs look so different. I'm gonna do a little pre-teaching of that. Here's what tangent looks like. Got an asymptote here, an asymptote here, and tangent goes like this. It goes through 0, 0. And you kind of need to know these halfway points, and you definitely need to know that this is pi over 2 and negative pi over 2. That's where the asymptotes are. And then hopefully you'll be smart enough to know that this is pi over 2, but half of that. So 1/2 of pi over 2, which makes it pi over 4. So this is just a preview of tomorrow. This will be where negative pi over 4 is. And then you got to learn to stretch and shift and move those. And then the next day we talk about the other functions we haven't talked. We've done sine, cosine, and we will have done tangent. And then we got to do cosecant, secant, and cotangent. Then there's one last thing, and that's writing a sinusoidal equation. And that's where I give you a graph that goes like this, and then I say, can you write me the equation for that? That kind of thing. That's the last thing I have to teach you. So that's the big picture of what this unit's like. And then there is a lab. We haven't had a lab in forever. But the lab has to do with taking equations like this that you can write, and then you learn how to do that for tides. So you can find a tide table that if you lived on the ocean, you'd know where to find the tides. Like you can go online or you can look them up in a paper or that kind of thing. That people all are kind of obsessed with when's high tide because it makes a big difference for their life if they live on the ocean. And so you can make an equation like this for predicting at what time of day your high tide will be. And that's kind of cool. So there's the big picture. All right, so let's do one more of these. But do you remember me saying that we weren't going to do anything this crazy? Yeah, we're not. This is just insane. So we're going to get rid of this. And we're going to get rid of the 3 over 2. We are going to leave it negative. But this has 3 changes instead of 5, which is ludicrous. So everybody right now, try number 11. Act like it's a test question. See if you can do it. I'll pause for a sec and give that a try. Okay, a few things I've learned over the years. Draw the cosine first. Yeah, that's off. I'll try again. And then go label it. It's just easier, quicker. Always draw the original one. And then go back and look at changes you need to make. Okay. Any kind of a thing that you need to redraw the graph, you wait till last. So we'll do that, flip, last. If you can factor it, you should. 2 comes out, x plus pi over 6. Notice you take that 2, and it's like you're dividing both of them by 2. So instead of dividing by 2, we times it by 1/2, and that's how we get this pi over 6. Then I need to do this 2 first. You have to do the numbering before you do the shift. If you shift first and then you renumber, it will be wrong. Not because I'm like psychic, but because you will have moved it to the wrong place. So we have to do the renumbering first. That 2 has to go in and get multiplied or divided. Everything by 2 is really what's happening. Multiplying on the bottom by 2 is like dividing by 2. Now rewrite my new numbers. Pi over 4. Pi over 2, which is like 2 pi over 4, 3 pi over 4, and 4 pi over 4, which is like pi. Now I got to move it, pi over 6. Oh, that's not fun. Pi over 6? What the heck is a pi over 6? What if I made this into 12ths? Can you do this? Yep. If I wanted to move it 1 pi over 6, would you agree that's like 2 pi over 12s? And I can see how far, this is how far 3 pi over 12 is. So it's basically most of this distance. Now I'm being as realistic as you'd have to be. We're going to move it over not 1 whole mark. So I'm going to take each point and take each key point, move it over not quite 1 whole mark.
It goes the other way.
Oh, is it going left?
Yeah.
Dang, okay. Now, we put it in blue. There, I think you can tell it got moved left. Now, what's the most common mistake? Yes. I haven't flipped it, you're right, and that is a really common mistake, but I also didn't do something yet that I should have done. Yes.
Mark your number.
Yeah, I need a number right there. Okay, and how far did it move? Well, if this is 0, this thing moved over exactly pi over 6. I can label this as negative pi over 6. I know it's going to annoy some of you because it's not on the same, like, every mark system. Like every mark, the other marks were out of 12. If you want, I can make it 2 pi over 12. But it's going to be the same thing. Okay. So now I've got it labeled underneath where it's sticking out here. And now the last thing is that we had a negative in the front. And that makes it flip. So now I'm going to take and make it red. And go from down here. And I think, yep, I would have taken that one. So, again, pretty gruesome. If you're able to handle these, you're going to be able to handle the test just fine. There's nothing even this hard. Yes?
So, horizontal reflection, you just put the negatives on the x-axis, and if it's a vertical reflection, you like flip it.
Okay, that was 2 things. Say them one at a time.
If it's a horizontal reflection, do you just change?
Okay, we will not do horizontal reflections. So you don't have to worry about that. Okay? So now say the other thing.
And then if it's a vertical reflection, it just completely flips.
Yes, if it's a vertical reflect, that's the kind we will do. You just have to flip them across the x-axis, just like I just did, the red one compared to the blue one, that kind of flip, yep. We won't do horizontal reflects. Okay. I think this is the part where you should do a few homework problems that are like this. They look like this. And if I were in your shoes, I would probably do one off of each page because I wouldn't want to do all of them. And I think if you did one off of each page and then you went and checked them, you'd be in good shape. So let's just give you a bunch of time where you can work on that today. And if you are stuck on one, please come up and ask. Remember that I said the worst thing we would ever do would be 3 things. Okay, so I would just throw out number 7. That's just gross. We'll never do anything that hard. But we could do ones like 8 and 9. Anytime there's been 3 changes have been made to the parent function, you might have to do that kind. Remember that amplitude is the number in front. The amplitude of this one is 1. The period is always 2 pi for cosine and sine, unless we have a number here. And if there's a number there, you divide by that number. So the period of this one is 2 pi over 3. Horizontal shift, that's also known as a phase shift. You have to factor it first. If you don't factor it first, you would think the horizontal shift is negative 2 pi. Negative 2 pi is wrong. It's not that. You'd factor the 3 out first. And that's like dividing by 3, you know. So there is your horizontal shift. And the vertical shift is just this last thing. I like to just say it's up or down. So there's a reminder of that, what the amplitude, the period, the phase shift. They call it horizontal shift, but we will call it phase shift. And the vertical shift would be. Okay? I've definitely covered it all. And this is the part where you just need some time to practice. Please take advantage of that and actually practice. And that's all I got for the video for today.